Okay, welcome everybody to the third WebEx face-to-face office hour. So we have been covered the first 5 or 6 weeks of lectures up to the part 1 and part 2 that covers how to plot the function and how to find the solution of the equations. And then we learned the some basic knowledge on linear algebra up to the singular value decomposition. Okay, and I'm going to share the first screen here. Okay, and as you see, I have uploaded your first PBL report, and I have that you can download it. You can download the sample for A grade for your midterm examination. Here that you can download it, and I shared your quiz scores here. If you see anything wrong, then tell me now. Mark Owen.
Yes.
Yes, you are. Is there anything wrong on your quiz scores?
I think
Please
it's
check
close to 100.
what problem you made a mistake. Okay,
Yeah.
I gave you the right answer on the quiz, so you can check whether your answer is right or not. And 백승열,
Yeah.
yeah, you check your scores. Is it
Yes.
right?
Yes.
Okay. Well, which point you missed?
Oh, question 6.
Okay. If you find anything to be fixed, then ask it in Q&A, so I can take a I can do the double check on your scores. And as I mentioned, now you can revise the attached file and yours, and to add your own comment on each of the problems. And for your first 7 or 8 weeks of this class, and then you may delete some part in the file that you have no interest or you don't understand, because you have to talk about your PBL report for your midterm examination. And you may try to explain or add in your own word that you understood from this course in this attached file with your name on each of at the first part at the first line of each problems or questions, and then you have to resubmit it on the assignment box that I will make soon after this class for your midterm examination. And at the end of this course, you will upgrade this your own PBL report for your final PBL report. And these are some of your own final comment after the first PBL report that you recently submitted. I have a look on your comment, and I will consider those comments to improve the last half of this course to reach the goal of this Math4AI class. Okay, now we are meeting in this room to review for the first 6 weeks. And I also attached a new file here. This is the final PBL, sample final PBL report that we generated in the last semester. If you take a look on this, then you will see how you're going to continue your study for this course. And also, I found some students have had a difficult time to make or to raise a question. So for those students, if you take a look on this final PBL report, then the questions and answers were made by the other student and by myself as well. So if there is a part that you don't understand, you can ask it again in Q&A until you fully understand on those questions. As I mentioned, there are 4 or 5 basic mathematical background that you need to understand before you pass this course. You will see it clearly in this report. So that will help you quite a lot. So is there anybody who took a look on it? Mark, did you have a chance to take a look on this file?
It seems like the file is the PBL for previous year or previous semester, and I looked at the previous semester from the website.
Would you say it again? I couldn't hear you clearly. Okay. Would you say it a little loud?
It seems like the file is the PBL report from the final semester, last semester. And I have looked at this final semester PBL report on the website.
Okay. So if you fully understand all those, then you are already well qualified to pass this course. But most of students are new, so some of you should have a part that you want to know more about it, and then you can ask those questions. You can copy and paste it in our Q&A on those questions, and then it will be answered until you fully understand those. So it will help you. Okay. So Mark, you know what to do. And 백승열, Mr. Beck,
네.
내가 무슨 말 했는지 이해돼요? 내가 지난 학기 PBL 보고서를 쉐어했으니까 여기에 이거 참고해서 보시면 요번 학기에 뭘 배워야 되는지를 알 수 있을 거예요. 그리고 이거 보면서 모르는 부분, 이 내용 중에서 이런 거 내가 이해가 안 된다 하는 게 있으면 그 질문을 다시 하면서 또 해보면서 그러면 그 답을 얻게 될 테니까 내가 주든지 또는 다른 학생들이 답을 줄 테니까 그래서 하나씩 이해해 가면 됩니다. 중요한 내용들을. 그러면 그것들 나중에 모아서 파이널라이즈 시켜서 모아서 제출하면 되고 또 그걸 발표시킬 거니까. 그리고 so you will have quizzes and this PBL report and presentation. Those will be the ground to be evaluated. Okay, in addition to your participation in this class. Okay, next. And if we take a look on this file, okay, let's see. Where is the okay, here. First month PBL report. This one. Do you see the Word file here? Word file 보여요?
네. Yes.
Okay. Yeah, this is the PBL report from the last semester. So in this course, yeah, we are learning SVD and gradient descent method and PCA and backpropagation algorithms. Yeah, the lots of questions and answers were made in here, so you can use those questions and answers in our discussions. Okay, and okay, this one. Okay. Okay, and I think I wanted to show you this one. First PBL. Is this the right one? Elijah. This is not. And not this one. Okay, this is what I wanted to share. Okay, here. Now you have a report that I expected. Some of you, including Mr. Peck and Mark Owen and Ashnawi and Liza did well, but I want you to improve, and all other students expect you to learn how to improve their report, so you are prepared for your midterm examination. Yes, so I will go through it. So how you can improve your PBL report. All you have to do is revise this in your own way until you understand what is written in this report to make your own midterm examination. So yeah, there are different formats are shared in here. You can choose your own format to organize the content in your own way. One student made a box here. So like in chapter 1, not chapter, week 1, yeah, week 1, and we learned how to draw the functions, including polynomials and rational and trigonometric and exponential and logarithmic function. Then we learned how to find the solution for the equation after we draw the graph of the function, and then we can expect where are the solutions, and by zooming it near each solution, then we can find all the solution set of the equation. When it is a periodic function, then we can find the couple and then use those periodicity to state the whole solution set. And next, in part 2, from week 2 to 6, yeah, we learned some basic knowledge on linear algebra, including vector operations and matrix operations and the Euclidean. These are not a chapter These are weeks. Week. And Euclidean distance and the norm, inner product and cosine similarity. And week 4, we learned how to solve the system of linear equations, and augmented matrix was introduced, and low elementary operations were introduced, then how to find the RREF, low reduced echelon form of an augmented matrix by using the Gauss-Jordan elimination. And then that RREF of the augmented matrix give us a big picture of how to find the solution set of the equations. We can have infinite many solutions, or it may not have any solutions. But in week 5, we learned among those all the cases, we can find the best possible solution for all cases by introducing the least square problems, which minimize the difference between AU minus Y, norm of AU minus Y. If you minimize this error, then we can find the best possible solution that fits AX equal to Y. Okay. In order to explain the least square solution, we need a concept of projection. And same idea can be used for the curve fitting. Those are the things that we have learned so far. And next thing is the singular value decomposition. We learned all of these in order to understand the singular value decomposition. That's the first important concept of this course, which is essential for the artificial intelligence. You understand, Mr. Bear?
Yes.
Yes. We have learned all these 5 weeks of content to understand singular value decomposition. So in 6 weeks now, you have to start to work with the singular value decomposition. You must have started to ask or share some on singular value decomposition. That's the things that you have to know. Okay?
Yes.
Okay. And some other students explained what the concept they have learned, and now you said you can do such and such like this. You can find the inner product of 2 vectors of higher dimension, and you can find the cosine similarities, and you can find the solution of the linear system of equations. And you still in the process of discussing how to find the solution set. And we will share it soon. So after you, in order to find the solution set of AX is equal B, then you make the augmented matrix, then use the Gaussian elimination to find the RREF. Then, now you can do figure out how many solutions this linear system of equation AX is equal to B has, and that gives you the way of finding the full set of solution. So, okay, I expect you to fill out your numbers for week 6, 7, and 8, and the total number should be added. If you're missing something or is written incorrectly, if the difference is bigger than if the error bound, then it will be counted. I will ask you to verify. Anyway, and also, yeah, you tried as much as you can in detail. And I was surprised that most of you did not fill out the keyword that you have learned. It should be written in here, not this. You, yeah, you should fill out this part in your own word. And anyway, and also, yeah, you did very well on your self-evaluation. Yeah, very well, like this. Yeah, many of you did very, filled it in very detail. And yeah, you explained how you have studied and what you have learned, such and such. And yeah, this is, yeah, you did on very well on the second part. But some did not evaluate the peer evaluation, evaluation 3. This is a 10-point worse. Yeah, you better write your colleague's name that you think you got some help to improve yourself. Okay, that's a 10-point worse among 100. And yeah, PBL participation. Yeah, you did. You did very well organized those. There are sample here and the list of the open problems that you have discussed. So I think yeah, if you missed something, now is the time to go through once to understand all the open problems. If there's any part that you don't understand, you can ask it in Q&A until you get the answer that you want. If you understand it now, after you read those finalized solutions for each of the open problems, then you can add your comment like this. At the end of, like this, you can add your comment. Summary or comment each weeks. Yeah, I think you did okay. Yeah, you have went through how to draw the graph, how to find the solution, and this is good. Yeah, you list out all the names of the student who was involved. And yeah, that's right. That's right. These are the names, yeah, and how to solve it. And now you can even solve. You can solve such as this equation, which you couldn't solve it before, with the method that you have learned. Okay, and same thing. When you have many solutions, still you can find all the solutions. Marx, he drew the graph of it to figure out x times sine 1 of x. Is this the right graph? Oh, no, it's right. Yeah, it's right. But you should have some kind of symmetry on the x-axis. Yeah. But anyway, you tried it. And derivatives and the secant line, how to find it, how to draw it. That's what you're going to learn in week 7 and 8. You already started it. And solve, how to find the approximated solution. Yeah, you know, and you learned those. And derivatives, open problem 5, matrix operations and the vector operations. And so you can summarize this. You don't have to make it long. Make it simple and clear. Title should be in English. for each problems. And here, yeah, you have learned this. Yeah, when you have the RREF of the augmented matrix, you will have this form in your computer by coding, and then this from here you can figure out how many solutions it can have. And I taught you how you're gonna do from here. Mark, yeah, do you understand what you're gonna do with this from here to find the solution set? I gave you some code so you can practice.
Look at the comment.
Do you understand? Do you have a confidence to find the whole solution set? Okay, I will see. Mr. Baekseung-yeol,
Yes.
yeah, I gave a note and code to find the whole solution set. Have you
Yes.
tried it?
Oh, yes.
You understand?
Yes.
Okay, that's I gave a PDF file that has a full explanation of those to find the
Yes.
solution set. You take a did you take a look?
Yes.
Okay, do you understand it?
Yes.
Okay, good. Okay, then share it so other students can see what you did. Okay. That's a very important part. Yeah, because we are in Math4AI class, so we have to deal with to find the best possible solution among those infinite many solutions. Okay. Open 6, open problem 6 here. Yeah, we found the lists, basis operations, and then matrix operations and solutions here. And what I gave you was the one that I recently made it for students of this semester. So it will be much helpful to find to understand the real solution set. If you try it, you will see. That's the best way. Okay, transpose inverse. How to find it? It's easy. Even for the large size matrix, now you can find the inverse transpose. But as you see, this command the only works when A has an inverse matrix. But we have to, not every matrix has the inverse, and not every matrix are square. But the matrix that we meet often are rectangular matrix, which does not has an inverse. So we have to learn how to deal with the situation that AX equal B, where A is a rectangular matrix, not a square matrix. So RREF is more preferable to understand the mathematics that really is used in mathematics for AI. This code only work for special cases. Okay. Excellent. And yeah, I shared you the open problems, and you really worked on. So and your idea was very impressive. And some students translated those examples in English. So that was very kind and also important. This was a good example for the cosine similarities, and it was good data. and it's here. You have to add the source of those data. Source of those data. And cosine similarity was used. And this works for the four-dimensional vectors. And this works not only for the lower dimensional vectors, but also very high dimensional vectors as well. Okay, so cosine similarity can be conducted in here. You had the questions to understand how to interpret those output. That's good. And Asnavi introduced some interesting examples. That was good too. This was a high dimensional vector, so dimension 7. And also the same code worked to classify those data. That's good. And problem 9, and norms and distance was found, and distance similarity. Open problem 10, and you discussed about cosine similarity. That's very good. I think I'm glad that you went through all those. Open problem 12. Solve right. Here, this is so solve right gives this has 4 variables and only 3 equations. So it does not have a unique solution. It either has infinite solution or no solution. So if you solve this and get some answer from this like that, then this is the only one solution out of infinite many solutions. Okay, so you need to find all other solutions to find the solution set. And I'm gonna teach you how to find the all other solutions. That's the case that solve AX is equal to 0. AX equal to 0. Homogeneous system of equation. Then it's easy to find the whole solution space for that, because the 0 vector is always a solution for AX is equal to 0. Isn't it? A matrix times the 0 vector is a 0 vector. And in that homogeneous system of equation, if you find the kernel of that matrix A, then you can find the free variables and the basis for the solution space. That's what I was trying to teach you. And do practice it until you understand that. And open problem 14. And you did okay. With 15. Least square solution. When you have the linear system of equation where matrix A is a rectangular matrix with a full column length, then in that case, you can easily find the least square solution. And in order to understand that, you should have a matrix whose columns are linearly independent. While you are solving those, you will understand what it is. But the matrix that is generated from the data that you have produced from your experiment in engineering or science or social science, those data form a matrix whose columns are all linearly independent. So in most of the case, you will have a matrix that can be used to find the least square solution. 배틀 것. 내가 이렇게 한 말
네.
이해가 돼요? 리스트
네.
스퀘어 해봤죠? Problem 15?
네.
이거 할 때 AX equal B, AX is equal to B를 풀 때 A
예.
트랜스포즈를 양변에 곱해줘서 그래서
네.
A 트랜스포즈 A가 역행렬이 존재하면 그러면
네.
그 시스템에 대한 솔루션을 구할 수가 있죠.
예.
그렇죠? 그러니까 그러면 그렇게 해서 구해지는 게 리스트 스퀘어 솔루션이라고 그랬죠.
네.
그게 항상 존재하려면 조건이 뭐예요? A 트랜스포즈 A가 역행렬을 가져야 되죠.
그렇죠.
그죠? 항상 그게 굉장히 중요한 조건이에요. 근데 여러분들이 데이터를 만들면 X1일 때 Y1, X2일 때 Y2, X3일 때 Y3 하는 식으로 데이터를 쭉 만들게 되잖아요. 그렇죠?
네.
이렇게 해서 이퀘이션을 만들면 그렇게 해서 만들어지는 행렬이 반델몬드 행렬이 돼요. 오차다 항식이 되는 경우에. 그
네.
반델몬드 행렬이 그렇게 데이터로부터 만든 행렬은 그 컬럼들이 다 1차 독립이 돼서 A 트랜스포즈 A는 사이즈가 줄어드는 가역 행렬이 돼요. 항상. 그러니까 여러분들이 이제 그 부분을 이걸 하면서 이해해야 돼요. 오케이?
예.
그 부분이 커멘트가 되는 것들. 어쨌든 그 디스커션을 통해서 여러분들이 이걸 이해하도록 해요. 김동현 군, 리스트 스퀘어 솔루션 꼭 필요한 거예요. 꼭 이걸 이해해야만 돼요. 그러니까
예.
직접 해보지 않고는 이해 못하는 거예요. 왜 리스트 스퀘어 솔루션 할 때 A 트랜스포즈 A의 역행렬이 존재해야지 그게 하잖아요.
네.
그러니까 언제 그럼 A 트랜스포즈 A가 가역 행렬이 존재하느냐. 그 조건이 이제를 알아야지만 이 리스트 스퀘어 솔루션을 구할 수 있는 거 아니에요? 리스트 스퀘어 프로그램을 적용할 수 있는 문제가 무엇인지를 이해해야 되잖아요. 이제 그걸
네.
이해를 해야 돼요. 구하는 거는 이 코딩으로 모든 문제 그냥 구할 수 있어요. 근데 이 코드를 적용할 수 있는 문제냐 아니냐는 건 여러분들이 판단해야 된다는 거예요. 그거를 이해해야 됩니다.
예, 알겠습니다.
해봐야 합니다.
예.
자, 그럼 여기 이거 대충 그렇게 해서 그러니까 내가 오픈 프로그램 16 싱귤라벨 디컴포지션을 해보라고 줬는데 여러분들이 이걸 지금 이제 해봐야 되는 거예요. SVD를. 자, 그래서 SVD 하고 그 다음에 미분으로 가서 도함수, 접선의 방정식, 그 다음에 이제 최대값, 최소값 구하는 거 대충 그렇게 하면서 중간고사가 되는 거니까 뭐 미분의 그 앞부분은 다 여러분들 고등학교 때 배운 내용이라서 쉽게 할 수 있을 거예요. Okay. Anyway, yeah. So now it's time to start the singularity decomposition and the derivatives and the secant line and the local maximum and local minimum. Before your final midterm examination. And then okay, midterm PBL report. And yeah, here as I mentioned, the first month's PBL report does not require this project proposal, but for this midterm examination, you are asked to just fill out the simple title and the abstract with your name and the reference. And just you don't have to do this project unless you really like to do it or to improve your grade for extra point. But I expect you to just think about how you're gonna learn, how you're gonna use the mathematics in our textbook for your own problems, which is related to your major or your interest. So just think about it. Yeah. If some of your idea should be good, then yeah, I may help you to go through it as your team project or your self-study to give you extra point. And the final comment was given, and that was very impressive. And now I added what you're going to do for the midterm examination by adding your work for week 6, 7, or 8 to extend your PBL report, which it should be better than this sample. 다 이해되죠? Everybody understand? Okay. Then next thing is PDF. Okay. Here. Okay. Why is not PDF? One more PDF. Here. Okay. Now we are in the week 6 singular decomposition. I think before the singular decomposition, yeah, we showed the LU decomposition and QR decomposition, and at last we covered the singular value decomposition. Here, but you have to know the singular value decomposition. LU decomposition is like this. LU decomposition. If the matrix can be written as a lower triangular matrix times an upper triangular matrix like this, then B is equal to AX can be written as L times U times X, which can be written as L times Y. B is equal to L times Y. If L is a lower triangular matrix like this, you can easily find dy because you know B and you know L. L1 times Y1 is equal to B1. So Y1 can be found easily. If you substitute Y2 Y1 to the second, then Y2 can be obtained easily. Y1, Y2 are substituted, then Y3 will be obtained. Y1, Y2, Y3 is applied, then Y4 will be obtained easily. So solving the linear system B is equal to Ly is an easy one. Then next problem is what? You know Y, which means Ux is equal to Y. Ux is equal to Y. You know what is X, and you know what is U, and you now have Y is specified. So solving only what you have to do is just to solve this. So if you have a LU decomposition of matrix A, then solving AX is equal to B turned out to solve Ly is equal to B first. Y can be easily obtained by forward substitution. Then next step is just to solve Ux is equal to Y. You now have U is known, Y is known. Then X can be easily obtained because U is this upper triangular matrix. So Y4 gives you X4. If you substitute X4, then X3 will be obtained easily. If you substitute X3 and X4, then X2 can be obtained easily. If you substitute X1, X2, X3, X4, then X1 can be obtained. So now you have X1, 2, 3, 4 easily by just substituting, backward substitution. So if you can factorize a matrix as a LU like this, then solving linear system of equation is very easy. This is an example. Next, QR decomposition is where if you can factorize the matrix A as a QR, here Q is an orthogonal matrix and R is an upper triangular matrix, where Q transpose Q is equal identity matrix, then solving this problem, minimize the norm of AX minus B. This is the problem of finding the least square solution, best possible solution. This problem turned out to be this. Okay, and then if A can be written as QR, then this problem turned out to be this problem, which is same as this one. And R, here R transpose can be cancelled, then you have this system of equation. This is a very easy problem to solve. Very easy problem to solve because Q is an orthogonal matrix. Okay, this actually this gives you the least square solution like this. By solving this, you can find the solution like this. So QR factorization is a method, one method to find the least square solution that you have learned in week 5. And this QR factorization can be done like this. So then, if you have a Q and R, then you have X hat can be obtained as R inverse times Q transpose B. 김동현 군, 위의 explanation 따라서 A를 QR로 바꿀 수 있으면 X hat이 R inverse times Q transpose times B가 된다고.
예.
그냥 리스트 스퀘어 솔루션이 그냥 QR로 구해지는 거죠. 그렇죠? 이렇게 QR 분해만 할 수 있으면 이렇게 됩니다. 리스트 스퀘어 솔루션을 그냥 매트릭스 프로덕트로 그냥 구할 수 있다는 소리죠. 그렇죠?
예.
그래서 이게 해보라는 거예요.
예.
그 다음에 이제 the last one and the most important one is singularity decomposition. Matrix A can be factorized as a orthogonal matrix times the generalized diagonal matrix times an orthogonal matrix like this. Okay? Then as you see here, this matrix is a very high dimensional matrix. But this diagonal matrix, generalized diagonal matrix, only has zeros and sigmas. Very simple. Mark Owen, this. So if you can factorize this matrix as this, then this problem, the problem involving this matrix A, can be considered by studying this simple matrix sigma. Only has K element, K non-zero element. All others are zero. So you can find the rank reduction of the matrix. This is an n by n matrix, but now you only have a K by K matrix, diagonal matrix, to be considered. Understand? This is the basic idea for the rank reduction. When you have a million by million size Google data matrix, you can make it as a 100 by 100 square matrix, whose diagonal entries are sigma i's and all others are zeros. Then analyzing this matrix is much simpler than dealing with this million by 2 million size matrix, isn't it? 백승열군 이해돼요?
네.
이 싱귤라빌리티 컴포지션 하면은 이 문제 AX equal B라는 문제를 푸는 것, 이 K by K 행렬, 이건 정사각 행렬이 아닌 M by N 행렬이고, 이건 100만 by 200만 행렬이고, 이거는 1000 by 1000 행렬이라고. 이 A에 관한 문제를 이렇게 1000 by 1000 다이아고널 행렬로 바꿔서 생각할 수 있다는 소리예요. 이게 랭크 리덕션의 키 아이디어예요. Okay? So this can be done by finding the eigenvalues of A transpose A and then corresponding eigenvectors. Eigenvalues of A transpose A and the corresponding eigenvectors. These are the square root of eigenvalues of A transpose A, and these are corresponding eigenvectors of A transpose A. So if you, 여기서 eigenvalue가 왜 중요한지들은 대충 알고 있어요? 선형대수학을 안 배운 학생들은 eigenvalue를 모를까봐 내 eigenvalue 개념을 설명 안 하고 바로 싱귤라 밸류를 정의해주고 싱귤라 밸류를 구하는 방법을 가르쳐주고 대응하는 싱귤라 벡터를 구하는 방법을 가르쳐주고 싱귤라 벡터를 구하는 코드를 준 거예요. 그래서 행렬 A가 주어지면 싱귤라 밸류와 싱귤라 벡터를 구해서 그 시그마하고 U하고 V를 구해서 프린트하다 그러면 A가 이렇게 생겼으면 U는 이렇게, V는 이렇게, 그 다음에 시그마는 이렇게 대각선 행렬이잖아요. 그렇죠? 그렇게 구하는 법을 가르쳐 준 거예요. 이 사이즈가 2x2가 아니라 3x2라든지 3x5라든지 100x200이어도 it works. 김정빈 군 이해해요?
네, 이해됐습니다.
이게 이 행렬 A가 100만 바이 200만 행렬이었을 경우에 이 싱귤라벨 디컴포지션을 하면 올소그랄 매트릭스 U와 V 그 다음에 대각선 행렬 시그마가 나타나는데 이 대각선 행렬 시그마는 그 디멘전이 훨씬 더 작은 그런 사이즈로 나타나는 거예요. 더군다나 이 시그마 아이들을 크기 순으로 큰 거부터 작은 거로 배열한다 그러면 위에 건 크지만 1000x1000 그러니까 1000x1000 행렬에 뒤에 한 500개는 굉장히 작을 수도 있잖아요. 그렇잖아요. 만약에 가장 큰 아이겐 싱귤라 밸류로 모든 싱귤라 밸류 나누면 제일 첫 번째 있는 건 1이고 그 두 번째 건 1보다 작고 세 번째 건 더 작고 해서 1000번째 500번째 있는 1000번째 있는 거는 아주 작은 숫자가 되겠죠. 그걸 제곱을 하고 세제곱을 4제곱을 한다 그러면 작은 값은 그 시그마 K 중에 작은 거는 0으로 굉장히 빨리 수렴하니까 별로 영향을 미치지 않겠죠. 그렇죠? 그래서 랭크 리덕션을 여러분들이 원하는 사이즈로 할 수 있는 거예요. 그래서 밀리언 바이 2 밀리언 매트릭스를 그 저기 50 바이 50 행렬 문제로 바꿔서 해도 에러가 별로 안 나게 원하는 결론을 얻을 수 있는 거예요. 그걸 이해해야만 여러분들이 그 어떤 문제를 빨리 행렬로 문제로 바꿔서 SVD 해서 랭크를 여러분들이 원하는 디멘전으로 낮춰서 컴퓨터에 집어넣어 줘야만 컴퓨터가 빨리빨리 계산해 주지. 컴퓨터에 그 100만 바이 200만 핵짜리 행렬을 집어넣고 계산하라 그러면 그 행렬 계산이 제대로 돌아가겠어요? 백승열군? 슈퍼컴퓨터라도?
힘들 것.
그렇죠. 근데 이렇게 가공을 해서 예를 들어 50 바이 50 행렬을 컴퓨터에 집어넣고 계산하라 그러면 빠른 컴퓨터는 계산을 어떻게 하겠어? 순식간에 하겠죠. 그렇기 때문에 알파고가 돌아가는 거예요. 원래 문제를 갖고 컴퓨터를 사용하려 그러면 컴퓨터가 제 역할을 못 하는데 여러분들 이런 수학을 통해서 랭크를 여러분들이 원하는 수준으로 낮춰서 컴퓨터에 명령을 주면 순식간에 답을 얻어주니까 그러니까 바로 다음 의사결정을 할 수 있죠. 그렇죠? 그 의사결정의 에러가 그걸 컨트롤하기 위해서 그래서 뭐 50 바이 50 행렬로는 좀 정확한 답이 안 나오면 뭐 500 바이 500 행렬이라든지 뭐 1000 바이 1000 행렬로 좀 늘려서 하면 시간이 좀 더 걸리더라도 정확도도 높여갈 수가 있겠죠. 그래도
네.
100만 바이 200만 행렬을 다루는 것보다는 시간이 100만 분의 1만큼 그 이상으로 더 줄어들죠.
네.
그렇죠. 이해됐어요? 이게
네.
왜 중요한지 이해하겠죠. So now I explained why this SVD is so important in AI study. Mark. So yeah, just try to practice what is written and to talk about what you like to know more about it. Okay? Mark, got it?
Yeah, I get it.
Okay. Then the next part is how to find the limit, how to find the derivative, and how to find the secant line, and how to find the higher degree derivatives, second derivative, then third derivatives, and then how to find the local minimum or local maximum, like local maximum and local minimums. After you learn this, you're going to learn how to find the local maximum or local minimum of higher dimensional matrices, multivariable functions. You will learn if this is a one variable functions. You will have when you have 2 variable functions or 3 variable functions, then it will be appeared in the higher dimensional spaces. Still, you want to find the local maximum or local minimum like this. Okay? Those same method will be applied. So you have to learn this first before you do study the multivariable functions and local maximum or local minimum multivariable functions. You need the matrix eigenvalues and the concept of eigenvalues and eigenvectors and singular values and singular vectors in order to understand it, in addition to how to find the derivatives. Those will be a key idea for the gradient descent method, how to find this local maximum and local minimum. Here it is different, isn't it? Before you learned how to find the dissolution of the equation here that cross the x-axis, but local maximum or like local minimum is not on the x-axis. So we need another way to find this local maximum and local minimum. Okay? Newton's method was used to find this solution that crossed the x-axis. Gradient descent method are used to find this local maximum and local minimum point, this critical point. Okay, Mark? Got it?
I understand.
So gradient descent method is very essential to understand the optimal solution and local maximum and local minimum for the multivariable functions. And this is a starting point. Okay, this is a gradient descent method. You have everybody should understand this gradient descent method. Okay, then you will go through the statistics. Those are the things you have to do now. Okay, any questions so far? Any questions?
No.
Okay, then I think time's almost up, so I'm gonna finish up. 이현규
네,
오늘 조용히 있었는데 자 오늘 배운 것 중에서 궁금한 거나 중요하다고 생각하는 거 얘기해 보세요.
중요하다고 생각하는 거는 그 SVD를 통해서
음.
그 컴퓨터나 중앙 제어 장치가 처리하는 양을 줄이는 방법을 통해서 훨씬 계산을 빨리 할 수가 있다. 오차를
그렇죠.
줄이면서.
그러니까
맞습니다.
원래 데이터를 가지고 그냥 컴퓨터에다 시키면 컴퓨터가 감당을 못해서 컴퓨터가 아무 도움이 되지 않아요. 그렇죠?
네,
그러니까 수학을 이용해서 원래 데이터들을 컴퓨터가 감당할 수 있는 그러면서도 우리가 원하는 정확도를 가지고 보장하는 사이즈로 바꿔주고 그 또 모양도 렉탱귤라했던 거를 스퀘어로 바꿔주고 그러고 이제 컴퓨터한테 명령 우리가 원하는 답을 구해달라 그러면 아주 쉽게 바로 답을 구해주게 되기 때문에 이제 컴퓨터가 진짜로 인공지능에 활용한 우리의 동반자가 되는 거예요. 그걸 컴퓨터를 인공지능을 이용하려면 이 수학 이론이 특히 SVD라든지 그레디언트 디센트 메소드가 에센셜이에요. 그걸 하기 위해서 앞에 다른 내용들을 배우는 거예요. 그러니까 해보면서 계속 질문하도록 하세요. Okay.
네.
Mark, yeah, final comment. Yeah, from what we have learned today.
That the important part is SVD and also gradient descent. I've heard about gradient descent, and I think you use it to minimize the error, like the least square solution.
Okay.
I also have a question.
Yes.
About the presentation. Is it recorded or is it live?
Since we have a small size class, I think we can talk in these meetings, but for those but may not be enough for all. In that case, yeah, you can make a record and then submit it. Then we can share it to be peer reviewed. Okay, I think we have a small size class here. So yeah, instead of taking the written examination, I will give you a simple quiz like what we had. And then after you finish up your PBL report, revised PBL report for your midterm, including the seventh week, 6th and 7th week materials, and then you may make about 10 or 15 minutes presentation of your PBL report, and then submit it. Then it will be peer reviewed. For those who cannot do that, then I will give a chance to give a live presentation in front of all others in our office hour. Is it clear?
Yeah, it's clear.
Okay. 자, 그러면 Miss Mark, you may write down your question and the answer that you got today. Okay? In
Okay.
Q&A. Okay? All right. 자, 다른 학생들도 all other students are recommended to summarize what you have learned today in Q&A. And if one student, if Mr. Peck write it down and Mark write down a couple of the statement, and then Mr. Kim or Mr. Lee can add on it as a reply, so it can, which will be helpful for others who couldn't join in this meeting. Okay, and then after in week 7 and 8, we will have midterm examination, and you can submit it. Okay. 다른 질문들이 있어요? 내가 오늘 홈워크 박스는 이번 주 말부터 다음 주까지 7주 말까지 열어놓을게요. 그러니까 이번 주가 6주니까 다음 주 7주, 다음 주 7, 하여튼 7, 8주에 저 중간고사 걸 열어놓을게요. 그러니까 먼저 제출, the first or the best, they will get the highest point. 그러니까 저기 제출 먼저 하고 그리고 Q&A에 논의하고 그다음 제출 먼저 하세요. 그러면 I will check them and I will give you a comment or a time slot for your presentation, or you can just submit it after that. 자, 이해됐죠? 대충 설명했는데 여러분들이 다 스마트한 학생들이니까 잘 이해했을 거라고 이해하고 이해한 대로 Q&A에 공유해 주세요. 만약에 그게 언클리어한 거는 내가 다시 윤문해 줄게요. 오케이. Okay, thank you for your attendance, and please share what we had today for others, and that will be all counted for your grade. Okay. See you in
수고하셨습니다.
2 weeks.
수고하셨습니다.
수고하셨어요. Thank you.
수고하셨습니다.
네.